Assalamu alaikum learners, how are you? Hope you will be fine. I am Tahira from FW Model School. This is my first lecture for class 8 subject math unit number 1 operations on sets. Today we are going to start one of the very interesting topic of math operations on set. This topic is very simple but it is very useful in solving higher problems in math. In this video we are going to discuss topics sets, types of sets, union and intersection of set, properties of set. First, coming into the introduction to set, we already know a set. A set is a collection of objects. Objects in the collections are called elements of the set. Here we have an example of set. The collection of counting number is a set. Each counting number is an element of the set. The collection of pencils in your briefcase is a set. Each pencil in your briefcase is an element of the set. Next we have a set notation. Sets are usually designated with capital letters. Elements of a set are usually designated with lowercase letters. Next we are going to discuss about description of sets. Here we can write set in two forms, roster form or set builder form. First of all we are going to discuss roster form of set. The roster method of specifying a set consisting of surrounding the collections of elements with braces. For example, the set of counting numbers from 1 to 5 would be written as, here we have an example of roster form. In this set we have 5 numbers 1, 2, 3, 4 and 5. This represents roster form of set. Next we discuss set builder form. In this method a set is described by some property common to all the elements. In set builder form notation has the general form. Here we have an example of set builder form. Variable such that descriptive statement, the vertical bar in a set builder notation is always read as such that. Next we have example of set builder form x such that x less than 6 and x is a counting number is a set of all counting numbers less than 6. Note this is the same as set 1, 2, 3, 4 and 5. This is same as we discussed the union set. Next we discuss the types of set. We have a first type of set, that is empty set. The set with no elements is called the empty set or the null set, and it is designated with the symbol. Here we use a symbol that represent empty set. Next we have some examples of empty sets. The set of all pencils in your briefcase might indeed be the empty set. The set of even prime numbers greater than 2 is the empty set. The set x such that x less than 3 and x greater than 5 is the empty set. Next we discuss subset. Here we have a definition of subset. A set A is a subset of B if every element of A is an element of B. If A is a subset of B and B contains elements which are not in A, then A is a proper subset of B. Here we have set notation of subset. If A is a subset of B, we write A is a subset of B to designate that relationship. If A is a proper subset of B, we write A is a subset of B to designate that relationship. If A is not a subset of B, we write here we use a symbol that represent if A is not a subset of B to designate that relationship. Here we have some examples of subset. A set A is a subset of the set B because each element of A is an element of B. In set A we have 3 numbers 1, 2 and 3, and in set B we have 5 numbers 1, 2, 3, 4, 5 and 6. These sets are set A is a subset of B because all the elements of set A are included in set B. So we can write these set, we use a symbol that represent subset. Next we have another example of subset. If set A is not a subset of set B because 3 is an element of A but is not an element of B. Here we have also two set A and B. In set A we have 3 numbers 3, 5 and 7. In set B we have 5 numbers 1, 4, 5, 7 and A, and we can say that A is not a subset of B because 3 is an element of A but is not an element of B. The empty set is a subset of every set because every element of the empty set is an element of every other set. Next we discuss proper subset. If A is a subset of B and A is not equal to B, then A is called a proper subset of B, written as, here we use a symbol and an example that represent proper subset. Next we discuss universal set. A set U is called a universal set if all the sets under consideration are subset of the set U. For example, if we have a set A and set B and set C, then The universal set is equal to 1, 2, 3, 4, 5, 6, 7, 8 and 9 because in universal set we includes all the elements of the given sets. Next we discuss power set. The collection of all possible subset of a given set A is the power set of A. It is denoted by, here we use a symbol for the representation of power set, and we have also an example of power set. Next we discuss equal set. Two set A and B are equal if A is a subset of B and B is a subset of A. It means is all the elements of A are included in B and all the elements of B are also included in A, and that we can say that A is equal to B. This represent equal set. Here we have some example of equal set. Here we have a set A. In set A we have three numbers 3, 4, 6, and in set B we have also three numbers 6, 3 and 4. In these sets the order of the numbers are changed. In these sets A and B the order of the numbers are changed but the numbers are same. So we can say that A is equal to B, and this is the representation of equal set. Here we have some and other examples of subset. If A is equal to 1, 2, 3, 4 and 5 and B is equal to x such that x less than 6 and x is a counting number, then A is a subset of B because every element of A is an element of B, and B is a subset of A because every element of B is an element of A. Therefore the two sets are equal and we write A is equal to B. Next we discuss operations on set. In this class on set, relations and function, we are going to see a very important topic known as operations on set. First operation is union. First of all, we are want to explain union. Union of two set A and B consists of all the elements in set A or set B also include common elements. Here we have another definition of union. The union of two set A and B is a set of containing those elements which are elements of A or elements of B. We write A union B. Here we have an example of union. We have a set A, and in this set we have three numbers 3, 4, 6, and we have another set B. In this set, in set B we have five numbers 1, 2, 3, 5 and 6, and we write A union B. First we write A union B. In this set we write all the elements of set A and B. Now we get a third set. In union we include all elements without repetition. Next we have an example of union. To understand this definition of union, let us see an example. Suppose we have two set A and B and we write this set for the better representation and for the better understanding of this definition. A is equal to x such that x greater than 5 and B x such that x less than 3. Then A union B x such that x less than 3 or x greater than 5. Next we explain union with the help of a diagram. Here we have a Venn diagram. In this diagram A is represented by the red circle and B is represented by the blue circle. The purple colored region illustrates the intersection. The union consists of all the points which are colored red or blue or purple. This diagram represent union. This diagram represent union set. Okay, next we discuss intersection. First we discuss definition of intersection. The intersection of two set A and B is a set containing those elements which are elements of A and elements of B. We write A intersection B. We write A intersection B. Intersection of set in union. Intersection of set. In union we use a symbol like capital U. For intersection the symbol is exactly the vertical version of union symbol. If we have two set A and B, that the intersection of two set is denoted with symbol. First of all we define intersection. Then for the better understanding of this definition we use an example. Here we have an example. A is equal to 3, 4, 6 and 8 and B is equal to 1, 2, 3, 5 and 6. Then A intersection B is equal to 3 and 6. If A is the set of prime numbers and B is the set of even number, then A intersection B is equal to 2. Here we have other example of intersection. Next we explain intersection with the help of a diagram. Here we have Venn diagram. In this diagram the colored part represents intersection of set. Next we discuss disjoint set. Two set A and B are disjoint set if A intersection B is equal to infinite. For example, A is equal to 2, 4, 6 and 8 and B is equal to 1, 3, 5, 7, then A and B are disjoint set. Next we discuss difference of set. If A and B are two sets, then their difference A minus B is a set containing exactly those elements in A that are not in B. Here we have an example of difference of set. In difference of set, this operation of difference of two set is similar to the subtraction of numbers. Whenever we have two set A and B, and in A we have three letters A, B, C, and in set B we have two letters A, D. The difference of these sets is equal to B and C. Okay, difference of set formed by all the elements in A that are not present in set B. We explain difference of set. In difference of set formed by all the elements in A that are not present in set B. Next we discuss symmetric difference. Symmetric difference of two set P and Q is that set containing exactly all the elements that are not in P or in Q, but not in both. When we discuss symmetric operation, let us see what is the symmetric difference. It is a difference again but someone same. To understand it, the best way is to use an example. Here we have an example of symmetric of set. Next we discuss algebraic properties. Union and intersection are commutative operations. Here we have a commutative operations of union and intersection. Next we have associative operations of union and intersection. Here we have a identity law, and last one we have a complement law. Two distributive laws are true. Here we have a distributive law of a set. Thank you so much. Allah Hafiz.